All right, the project for today in the garage. Normally around the shop, you know, to blow air on things, to blow off shavings and whatever, I use this kind of a thing, and probably a lot of people use a similar deal. I mean, they come in different versions, but it's just a standard air blow gun. And at the bigger shop, I had taken one of those exact same ones, taken the end off of it, and I purchased these things off Amazon. You can buy these in a set of two. They're kind of expensive. They're like $19 for two of them, so they're about 10 bucks a piece. And these will thread. They sort of thread in here. This isn't really the right thread. I think this is a 10 millimeter by 1 pitch thread, and this is I bought these with an 1/8 inch NPT, so it's pretty darn close to the same pitch, and it actually does thread into these things. And you can just do this and buy an air gun like this and put a bunch of you know, Teflon tape around here and everything, or maybe just glue it in there with some whatever, liquid nails or something, or I don't think Loctite would work too good there because the fit is so loose, and be done with it. And that's what I had done at the bigger shop. But when I went to looking for that thing the other day, somebody's borrowed it and not brought it back to me, or I've misplaced it or something and I can't find it. So I'm kind of like, I need to make something else here to do this. And when I bought these fittings off of Amazon, they were well, let me go back here. These things, you can buy sets of these these tips like this, and this is like only about $6 for all of these, $6 or $7 off Amazon. And it comes with a number 8, 10, 12, 14, 16, and 18 size needles. Or they're not really needles because they're blunt ended, they're flat ended, they're just the size tubes that are on these things. And this is kind of nicer than if you can buy this thing with these other nozzle tips, and you know, you thread them in there, and you can they come with different size tubes. But if you break one of these or do whatever to it, you can't really get a separate one of these. It's kind of like you got to buy the whole set of them, and you got to thread this in and out every time. So this thing's always coming loose on you, and it's kind of annoying to use it this way, even though it does work pretty much the same. But I like this setup too, also because I can buy these long needles that go into this connection, and it's nice for blowing out in deep holes like I do at the big shop with the gun drills and stuff and things like that. Or I even have one of these on the end of I guess it's one of those barbecue syringes that you know, you use barbecue and stuff to inject salt and stuff into the meat. But I put this on it, and I put tapping fluid in there, and when I need to get into way back into a hole that's back into a bore, I can put the tapping fluid in there with this kind of a setup, and it works good for that too. So back to these things though, I wasn't happy with the quality of these when I got them, and I tried to thread it in there. See, it doesn't really, you have to fiddle with it to get it to go in, and eventually it does go in there all right. And I even had to deburr them, and I wasn't happy with the quality of these. And they're brass as well, and so I'm kind of feeling like the brass would wear out, you know, on the thread here, because this little tip of this needle, this little square, you know, end of this just barely connects with that thread as well. So it's going to kind of I don't know, maybe not last too well inside there. So I thought, what if I could machine this onto the end of you know, myself, and I've got the dimensions. You can just search on the internet as well, and you can get the dimensions for the male end of a Luer connection. And so I got a drawing on that. I'll show you on the computer, but I am not totally happy with this air nozzle for a couple of reasons. Because when you have this all in there and you're blowing junk out of a hole like this kind of, it of course blows all over your hand. That's one thing I don't like. And this is very difficult to throttle the amount of air you want as well. Sometimes you want to do that. You want to just blow a very little amount of air in there for some reason, and not just, you know, blow a whole bunch. And you can't really throttle these very well. It takes a lot of care in the way you're pushing this lever on this particular kind of air nozzle. So I saw this thing off Amazon, on, you know, a picture on Amazon, and I thought, hey, that lever has a lot of travel in it, and so maybe I could throttle this thing nicely. And it comes with these two tips like this, and it's not expensive. This thing's like, I don't know, it's $10 or $11. And I thought, well, I'll just take this and I'll cut that one off, and I'll drill and tap it for the 1/8 inch MPT, and you know, I'll be done with the whole thing, and this will just be able to throttle. So that original idea is pretty good, and these thread in and out of there easily with a little O-ring seal, and so I thought that would work. But when I got this thing and tested it, it's either like full on or full off again, like the other one. And in fact, this one's even harder to throttle than this version is, believe it or not, even though this seems like it would be harder. And so I thought, well, maybe I can do something about that. So I drove this rivet out, and I think I can reuse that rivet the way I drove it out of there. And I took this apart on the air valve here, and here's a spring that of course returns it to the sealed position. And this plunger here has a rather severe taper on it, and you know, and their whole intent is that you get your air blown through there as much as you can, and for the purpose of what this is designed to do, that's great. But I thought, well, could I make a new valve or modify this valve? So I took this out and I looked at the bore in here, and the bore looks pretty darn good. In fact, it looks real good inside of this brass thing. And of course the air comes in this way, up the thing and in, and it goes out and out the end of this through a hole in here and then out. And if I could make a more gradual opening here somehow of this plunger, and so I've designed a new plunger that I can use, so I don't have to remake this in this air nozzle, and I think that'll work. So to begin with, what we're going to do is make this Luer connection that fits, that'll thread into the end of this this thing here and mount on here similar to this. Okay, with this is a half 20 thread on this particular thread, and then we'll have to machine the male part of this inside of there. Of course, you can't get a threading tool between this ID piece and the thread, so we can make this in two parts, and the inside part we can stick in here and either press it in or Loctite it in or something like that, and we'll have this whole fitting just like this, but it'll be kind of like this with the bigger thread that'll thread into this blowgun like that. Now, in thinking about that, I also, because I have access to a tool and cutter grinder, I ground this special thread tool to thread this. This particular thread has a double start thread, and this is the dimensions of the threading tool, the way it needs to be. And then you have to put a 2-start thread in there, which the thread has a 5mm pitch, but it's 2 starts, so there's 2.5mm pitch between the threads in essence. So that's the whole idea, and that's the kind of the little project that this video is going to be about, modifying this air gun here, or actually modifying the valve on it, not really the air gun itself, and making a new end piece to go in here to be able to connect to these syringe type tubes. So let's go to the computer and look at the CAD models and stuff and see how this might work, or is going to work, I should say. All right, here's the CAD file, or the model that I modeled of this connection. If I look at the, let me go back to here and just show you where I got these dimensions. If you just search for male Luer connector dimensions, and then I scrolled down to this drawing here and printed it out on my printer, and these are the dimensions that I'm going by as far as the thread and everything, and the diameters and all that stuff, the taper and all that. So that's where I got the information. But you can see here there's like, oh, many of these kind of connections. The medical industry uses these, I guess, and they use these for all kinds of stuff. And I'm just using them for my little application here, but you can see all these different kinds you can get. So anyway, that's where I got the dimensions from, and so I designed this thing. So this is going to have a half 20 thread on this end of it. Let me cut a section through this here so we can kind of see what we're looking at here. And I turned it around because this is the way we're going to start in the machining process. We're going to turn this OD with all these angles and angle down this 45, and turn a wide enough area in here to get the parting tool in. We're going to ultimately part it off. We're going to drill the ID and drill this ID here where the thread is, and or as close as we can to the size. We might have to bore it a little bit, and then I'm going to run a 5/16 end mill in here and just plunge it in until I get this flat bottom here. I'm going to thread a half 20 thread and knurl this OD right here. So that's basically going to be the first operation. Let me turn off the ID piece here, and you can kind of see. So these are the features we're going to do on this side, and then we're going to turn it around this way, and we're going to cut this double start thread with the threading tool that I already showed you in the video. That lead and this lead here. That should be pretty straightforward. It's already going to be, for the most part, faced or parted off to length. I might skim the face a little bit just manually. On this little Haas lathe I have in the garage here, I can kind of manually do stuff, which is probably the way I'll drill and flat bottom this hole with the end mill. And then I'll just turn this OD with the CNC part of the machine and thread it as like I described, and then part it off manually again, and then we'll turn it around and just maybe finish bore this ID if we can't get it close enough with a drill, and turn the thread. We'll be holding on here on this half 20 thread in the collet, in a 1/2 inch collet. Not my favorite way to hold something, but I don't think the cutting forces will be very high here to cut this thread in there. So that would be that part of it. And then we're going to take another piece of material and turn this OD to match whatever was left on there, so that it has a nice fit, to probably use Loctite to hold it together. And we'll turn this taper and drill it and turn this taper. That would form the sealing part of the Luer lock seal connection. So that's basically what that fitting will be. And of course this this diameter here will be turned in relation to that O-ring so that it'll seal in the blowgun itself. And I'll just take one of the O-rings off of one of those pieces of the blowgun came with and use that. Now on this is the plunger I've designed, and we'll have to try this out a little bit to see how it works. But what I want to do is cut a this is of course the O-ring grooves that are already in the existing plunger as you saw it, and the outside dimensions here are pretty much the same, but this diameter here will fit close in the bore, so we'll turn it intentionally to fit whatever size that bore is in that brass piece that's in the gun already. And then we're going to cut this with an end mill so it gradually tapers out. So as we push in on that plunger, we should increase the size of this air passage here until it gets out to this point where these other two will let it flow more air. So we can get a bigger quantity of air when we push it all the way back, but we can start, and like I say, with a little bit of air coming through this little passageway here as the O-ring just comes off of its sealing point. Now, I don't know, I might have to adjust the size of these things a little bit or something. This is all guesswork here, but other than that, this is basically the same dimensions as the existing plunger. The spring will fit on here, and it's got kind of a little bit of an interference fit on the spring, so it stays on there. So this is what we're going to do. First, we're going to do this thing here, and like I said, we're going to start turning it this direction back in the bar, and we're going to use some steel probably for this. I think I got some a leftover piece of, I don't know if it's 01 tool steel or water hardening. It could be one or the other. I can't tell, but I think it's something like that. And then because I want to make this steel, I could even heat treat it, but I don't think I'm going to do it, so that it would be harder in here on the thread and it would kind of hold up better. And I think I got a little piece of bronze that we can make this internal piece with bronze, so it'll made up to that taper a little bit nicer with the bronze material possibly, and be a little softer for that reason. So that's the plan. And then after we turn that and make that work, then we'll make this little plunger thing for the valve. So anyway, that's the plan, and let's get to the machine work now. All right, we got to put tool number 1 in here. I use this as a reference tool, so I have to face the end off. So I'm just going to do this manually and set my Z0 of my G54 offset right there. So I'll go over here, offset, and set that 0. And then we'll put the first tool in here. That tool actually doesn't really do anything. I'm roughing the whole thing with this tool here. Run the part. I got it starting out kind of far here. I should set it in a little bit, I guess, but just for a few parts. I'm going to turn a few of these. Now it'll take a cut. I'm taking a very shallow depths of cut because it's plunging into the stock here on part of this, and with this very fragile 35-degree diamond insert, I don't want to break the tip of the insert off. So where it's making that O-ring thread relief kind of O-ring groove, and on the back side where it's cutting that chamfer, the 45 chamfer on the other end of the part, it's plunging in, so I'm only taking like 15,000 step to cut, just to keep from breaking. This insert has only a 8 thousandths tip radius on it. So that's the whole roughing cycle. It's taking kind of a spring pass over the roughing cycle. Then I'll put some stuff on here, and this will be the finish cut over it. I'm trying to run this without any coolant or anything on it, so you can kind of see what's happening here. Otherwise, you know, it would be throwing coolant all over the place. Okay, I'm going to get rid of that. I've already run a few of these, so I'm not going to check any dimensions here. Now, I'm going to run the knurling tool to knurl that OD. I have found the best way to do this just to put the oil right here. Okay, and that's pretty much that. And here's the next up is the threading tool. here. This is a 1/2 inch 20 thread, or 20 pitch thread. Didn't have exactly the right insert for this, but I'm using an 18 pitch insert, but it seems like it fits all right to the thread is kind of loose on the nozzle itself, that air gun, so it seems to work all right. Now here's the drill. I'm just roughing this hole out. Well, this is actually the finished ID of the thread, like I discussed on the previous part of the video as well. I'm using Tap Magic for the cutting fluid here. Seems like it works all right. Okay. Taking very shallow depths of PEX here because I didn't want to. I'm not really using any coolant to speak of, so I didn't want to see how hot the drill is. I didn't want to get things too hot. So let's move that out of the way. Now I'm gonna kind of deburr things a little bit here. In production, if I'm doing this like on a CNC lathe, making a lot of parts, I would probably have a piece of sandpaper here. I would probably run the turning tool back over that knurl kind of to chamfer the corners of it, because the knurl throws up a lot of a burr where it starts and where it goes off apart like this. But in this case, I'm just going to sand it a little bit. I also want to polish this where that O-ring seat is there, if you will. See, I'm going to hit this with a little Scotch-Brite here. Okay, so you can kind of see what that's looking like now. I know I said in the video I was going to use an end mill for this, but I decided I'm just going to feed this little boring bar in and out of that hole. Gotta be careful, and when you grab chips like that, you can cut yourself real easy. Okay, so that's the bore where the internal piece is going to go into. It's not really critical because we're going to make everything kind of fit up to that. Here's the parting tool. I'm just going to part the part off like that. And that's the turning. I don't really want to touch this part. It's going to be pretty hot. So that's the first side of the part. And then we're going to turn it around the other direction and do the other side. The Dorian cut knurling tool really works nice. Very simple, and it just feed it on there. So I made about 4 of these sample pieces now. So now we'll turn around the operation and do the thread. Well, actually the hole, we're gonna have to chamfer the hole a little bit. I think I need to do that, and then thread. Face it, chamfer it, thread it. And this part of it should be done. I'm doing the other end with the thread. It's not really a lot to see here. Just face it. Put in the counter, kind of countersink the end of it a little bit here. And then the thread. Trying to get these tool holders off without hitting the camera. Okay. Let's see. I don't know if you're going to see too much for the thread here. Let me reposition this kind of like that. You might see a little better because it happens pretty fast here. This is a pretty steep pitch thread. Doing a double start thread here, so it does the first thread and then it moves out. I don't know if you'll be able to see it or not. It moves out its start point half the lead there, and then does a second lead. You see it kind of moved out a little bit between the leads, and that's basically the way you do it on this kind of control. You just step out half the lead for the next passes. And that's it right there. That's all there is to it. Okay, there's the thread. You just saw it being cut. Tried to deburr it a little bit and clean it out. Did a 5mm lead, 2 starts, so 2.5 millimeters between the starts. Offset. Put it in a handle jog. Now, okay. Offset. Tell it that's Z0. And we're going to start a new part. I think I could actually press these two parts together too, instead of using Loctite. Okay, that's the roughing passes. Here's the finished cut. Might try to do that. Let's see if I've got this the right size for that. Try it here. See that? Let me mic it and see. I might try to just press this together. Let's see. That measures about exactly with the calipers. Wherever I put the caliper. Calipers on this thing measure about a little less than 335. And this here, I just mic'd it. It's about the same size. Maybe I could press this together. Let me try that. I think I'm going to take a little bit more off of the OD of that. I don't want it too tight because if I have to push it out of there, I want to be able to do that without too much trouble. It's another couple of 10,000ths. That should be, according to the measurements, let's see, we're about a 0.5 under the nominal size. This is that would probably go. I might try that and see. Does this get tighter as it goes in there? And then we're going to spot drill. The only reason I'm doing this is that little drill tends to wander a little bit. I just try to drill that without the spot drill. Little stuff on there in case. You probably can't see it in the video because the collet chuck's blocking it, but it goes. It's going beyond the end of the flutes of the drill. So I thought it wouldn't hurt. Put a little something on there. Now I'm going to part that thing off. This is, I got to cut this, grind that off, because it's kind of, the drilled hole comes in there, but it's pushing the metal into it. I'm going to start it in here, see if I can get it sort of square. I just clamped this vise on the table. It's not indicated or anything. That's why I didn't take too much care I actually intentionally put it all out of whack so that I wouldn't get mixed up with anything. Let's see. It's going in there all right. But when I get close, I want to stop. This isn't the exact best situation. I can't really turn the vice handle on this. With this, let me just show you what's happening here. See, with this coolant guard on this machine, you can't really turn the vice handle. Okay, so it's kind of a little bit awkward doing this like this. I don't really have a bench vise set up in my garage here. I could just do it in that, but I don't really have that. I'm going to put one of these other ones on here, kind of like this. As soon as I get this opened up, and I had to turn it by hand here. Okay. Just so I don't, because that little female taper, or male, I should say, tapered end piece on that thing gets sticks out beyond the end of the fitting. So I don't want to hit it, smash it if I'm trying to press this all the way in. seemed like that worked all right. Okay, see, it sticks out beyond the end there. I don't know if you can see that. I think that's going to be all right. Okay, let me see it threaded in here. Like this. Get one of these, let me get a little bit further out here. Get one of these needle things. See if we can put it in there. Seems like that works all right. Okay, we're back here at the lathe. I have an air line over here right now. You see, plug this into the air. I haven't modified the valve, I just screwed it back in there. See, but I can't, it's like, can't really throttle it at all with this thing for some weird reason. It's like full on, or let me try one of the other tips, the bigger ones. This is like a, the number 8 tip. See if it goes in there all right. See, but it's like, no matter how slow I open that, this is either full on or full off. So now we're gonna make the other piece. Here's the smallest tip from that set, which is like a number 18, I think. And this can come in handy if you're trying to blow shavings out of a little tapped hole. This would fit in probably might even fit in a 256 hole, pretty small. And you can blow the shavings and stuff out of the hole with this. If you kind of poke it in there and push the shavings down and then run the air, you can kind of get them to compress in a way, and then they blow out of the hole. Very handy. So you just switch out the ends like that. It's kind of a medium-sized one. Put it on there. See, that's really need to do the valve thing next. So that's that part of it done. And the whole thing just threads into the end of this thing. Don't really, except for the modification of the valve here, I wouldn't really have to do anything to this air gun. In fact, it would work the way it is if I didn't want to throttle the air, which is about the same way I had the other one. But anyway, so that's the Luer fitting on the end of the air gun done. Z0. I've stuck the stock out 2 inches from the collet because that's what's necessary. I'm going to calculate the Z0 there. I'm going to start our program. Start turning the, roughing the OD. It's the same bronze material we used to make that centerpiece for the Luer fitting. So that would be the roughing part. Now we're going to do our finish cut. I'm going to hold this on here a little bit. Try to eliminate any kind of chatter there might be with this. As it gets up closer to the chuck or the collet, I don't have to hold this on here, but out at the end, I just want to make sure that it doesn't chatter on me. All right, I want to make sure that we have a, oh, bumped the camera there. I want to make sure that we have a decent fit here. Let me try the little, the valve body itself on here. Pretty good fit. Don't know how much air is going to leak by that initial, thousandth of an inch clearance, but should be all right. Now, in order to change to the grooving tool, in order to cut this groove, I have to run this tailstock up right there. And I don't really have a center in the end of this, of course, obviously, but I'm just push this live center. It creates a little bit of a dimple in there, but I'm not really too worried about that. So we're going to start here, and we're going to cut this groove first. It roughs out both grooves kind of, and then I got to come back and adjust the offset a little bit, because for some reason this groove here cuts a different diameter than this one up here with the same tool. So I separated out each groove to separate cycles kind of, so I could adjust the offset independently on each one. So that one should be 140 something. Should be 146. And it looks like it's 150, so I'm gonna have to come down 4 thousandths. So I'm gonna run that one again. Minus 0.004. I'm gonna go 3 to allow me some polishing. Tool 7, I think it is, yeah. I'm going to rerun that groove by itself, and then I'm going to run this one up here. There's a groove right up here, as you remember from the model. See, there's not really even enough force to turn this live center at that point, but it does enough to keep it from chattering, which is all I really want it to do. I'm liking that. Now, I'm going to run this other one. Actually, I can back this off now because I don't need the center anymore. This one I had to adjust smaller the last time I ran. I've already run one of these just to get everything sorted for the video, kind of. Let's see, that's about 6 thousandths. I'm going to come down another 5 on that one, so go minus. And we'll go N3, I called that. Okay. I'm going to rerun that again, and then we're going to polish the. All right. That should be really close within polishing. Yeah. Okay. So now, should be able to polish these a little bit. I didn't really want to make the program real complicated with finishing cuts and everything. Kind of programming this manually at the machine, and I just wanted to do it as simple as possible. And just round these corners off a little bit here. This file has kind of a safe edge on the back of it here, so. Go back in here a little bit. Okay. Stop. Now we got the parting tool to run, just to part it off. Parting it off a little bit long. And that's the basic plunger. We're gonna have to do this end. I gotta put a collet in there, appropriate size, and do whatever I gotta do here for that little boss for the spring. And after that, it should be ready. I gotta put it on the mill and mill these little notches that I showed. So I gotta figure out how to do that too. All right, here's the other end, N5. Just put this at the end of my previous program. I'm going to come in here and just cut that little boss for the spring thing. Maybe do a little bit of deburring too. Reposition it a little bit here. Okay. A very simple turning roughing cycle, and then a finish cut on that same cycle. So that's the rough cycle. Now we're going to just finish cut that thing, and then I set the offset out, so I'm going to adjust it appropriately to get the diameter. This is a little bit critical here as far as the diameters goes. So let's see, because otherwise the spring's not going to stay on there. The other one was 188 thousandths. Right now, I've got 192, so we're going to come down about 4 more thousandths. That should be it. So minus 0.04, and we got N6, I think I made that. Okay. Oop. That didn't look good. Had to check my program here. It worked the first time I did it, but now something is not right. Let's not be calling up the right tool offset or something. N6, right? Oh, T. I didn't even call it the 2 insert. Let's try that one more time. Forgot to totally call up the tool. It already had the tool, the active offset active the first time I ran it, but I forgot to call the tool up on the finish cut if I was going to run it separately. 188. That should. Let me check. Let me get the little spring here. Make sure that kind of stays on there. That seems pretty good. I'm gonna have to deburr things a little bit here. Now I'll put the other one in because I got 2 pieces I made. We check the overall length. Make sure that seems pretty good. It's my other piece. I'm gonna have to manually kind of I'm gonna have to I'm just going to do this manually, cut that tip off that the okay, that should be all right. Now N5 I think is where I started this. Like I said, I just programmed this after the M30 on the other program, the program turning the other end of it, so I wouldn't have to make a whole new file and everything. Okay, roughing, finishing. Check the diameter, but it should be good because I didn't change anything. Yeah, it's all right. Now, do a little deburr on the that's it. Now that's our 2 plunger pieces. And now we can cut those notches in the sides here on the mill. I got to set that all up. I just, as you saw earlier in the video, I just clamped the vise on the table and I didn't line it up, so I got to indicate the vise in and program those to cut those. That I'll use CAM software to program because it's a little bit more complicated than just manually programming it because of the shape I've got of that kind of ramp on the groove. So anyway, see, these are going to go in here. Now the O-ring kind of seals on this chamfer here to totally turn the valve off. So the way I'm kind of doing this to begin with is I stick this piece in here. I just kind of measure it for roughly, so it sticks out about 1/4 of an inch here from where that angle ends on the piece. And tighten this up so the collet's holding it pretty good. That's the way I put it in the collet block first, and then I run it over to here because it's because the stop is going against the actual part here. It's not critical, but just to show you, I got this about 1/4 of an inch out. Again, let's run the program. I don't know why, but for some reason on this color here, the camera doesn't really focus that good. This action camera has trouble focusing on certain kinds of, I don't know if it's the lighting. I mean, the lighting isn't very good in here. See, after each notch, I have a program stop. Goes over there, it stops, and then I can switch things around here. I'm going to do this so I don't get in the way of the camera too much. Okay, and so that's it. Here again, just stick this in here. Loosen this. The part will come out of there. Just enough. It's a very light milling operation, just enough to hold it. So we can put these passages or notches for the air passages in there. So now we got to put this together and see how it works. Okay, I thought I had the camera running when I was putting these O-rings on, but I put the O-rings on one of the pieces, and it now just goes into here like that, and we put the spring on here. Stick the whole thing inside the body of the air gun. And wrench to tighten this up. Right. Now put the handle on. Say I drove this rivet out with a punch, right? It kind of has a little dimple in the middle where they peened it over, and I just stuck a punch in there and drove it out, and it kind of collapsed the end of it. So I think I can reuse it, just re-expand it, but I'm not going to do that right now. But that's the whole thing put together now. Let's see how it works. Put the airline on here. Okay. I see the air. You can't really tell so much with that smaller tube only flows a certain amount of air through it. Let me put here's this set with the larger tubes on it. Yeah, see, I can flow. I don't know if you can hear that. It's close to the microphone. Flowing very little amount of air. See, now I can throttle the air. So you can really tell with the bigger diameter tube on there. These smaller ones, the cross section is only so big. Of course, you can't, even with the small passage on that thing, it's only going to flow a certain amount of air through it at all anyway. But I can. It actually, you probably can't hear it, but it actually is flowing air right now. So this is the 18 gauge needle, which is really handy for small holes and blowing stuff out. This one here, what size is that? It says it's the 12. You can see, you can hear it. Doesn't go, I mean, can't get it like real slow. It probably has to do with the clearance between the bore, this part of the OD here of these pieces, and the bore in the brass piece in there. So maybe if I made that really close fitting, like almost a lapped finish, might really throttle it much better. But this is good enough. At least I can reduce the amount of flow. See, so anyway, that seems to be working acceptable to me anyway. And you can change these tips just like that on there. So that's the air gun completed and put together. Hope this was of some interest to y'all, and thanks for watching.